Question number 1. Triangle A prime, B prime, C prime is the image of triangle ABC after dilation centered at the origin. The coordinates of the vertices of triangle ABC are A, -2, 1, B, 2, 4, and C, 2, -3. If the coordinates of A prime are -4, 2, the coordinates of B prime are... Okay, so for this question, we're given A and A prime, and we know it's a dilation. So using those two coordinates, we can find the scale factor that was multiplied to A to get A prime. So here are the coordinates. Okay, so what times 2 gives you -4? It's times 2, right? And then 1 to 2 is also times 2. So the scale factor here is 2. And we're given B, right? It's 2, 4. So all we have to do to get B prime is multiply the two coordinates by the scale factor, which is 2. So 2 times 2 is 4, and then 4 times 2 is 8. So the coordinates for B prime is 4, 8, which makes 2 the answer. Question number 2. In the diagram below, a plane intersects a square pyramid parallel to its base. Which two-dimensional shape describes its cross-section? So for this question, a plane would kind of look like a flat sheet of paper that slices through the object, right? And the cross-section is just the image that shows when the two things intersect. So when the plane intersects the pyramid, what is the shape of the intersection that you see on the plane? So for this case, it's going to look like a square, right? So the answer is 2, square. In the diagram below, triangle CDE is the image of triangle CAB after a dilation of DE over AB centered at C. Which statement is always true? For this question, it's saying that triangle CDE is the result of triangle CAB after it's been dilated. So what that basically means is that these two triangles have to be similar, because dilations only change the size of objects but not the shape. So we can say that angle A is going to be the same as angle D, angle B is going to be the same as angle E, and angle C is just going to be angle C. Looking at the answer choices, it says sine A, but sine A is basically the same thing as sine D. And cosine A is basically the same thing as cosine D. So what we can do, since the line segments here are all line segments for the dilated triangle, we can just find sine D and cosine D and match it up with the answer choices. So based off of SOHCAHTOA, sine D is equal to CE over CD, and cosine D is equal to DE over CD. Looking at the answer choices to see which one is true, number 1, sine D is equals to sine E over CD. That's true. Number 2 does not match up. Number 3 does not match up. And number 4 does not match up. So number 1 is the answer. Question number 4. A regular pentagon is rotated about its center. What is the minimum number of degrees needed to carry the pentagon onto itself? So for a regular pentagon, to find the number of degrees needed to carry itself onto itself is just 360 over the number of sides that it has. This only works for regular pentagons since all the sides and angles are congruent. But if it was like irregular, it wouldn't really work, right? So 360 over the number of sides, 360 over a pentagon has 5 sides over 5, and that gives us 72 degrees. So number 1 is the answer. Also, it says minimum, so 360 would work, but it's not the least amount of degrees that it would take to carry itself onto itself, right? Okay. Question number 5. On the set of axes below, triangle ABC is congruent to triangle A prime, B prime, C prime. Triangle ABC maps onto triangle A prime, B prime, C prime after A. 1 reflection over the line y equals -x. That line is going to look something like this. And as you can see here, if A was reflected over this line, it would be somewhere here as A prime, not as B prime. So number 1 does not work out. For number 2, reflection over the line y equals -x plus 2. That's also going to be a reflection over a line that looks similar to this, but it's going to be a little higher. So it still wouldn't make sense because A reflected over here, it's going to have to be A prime, not B prime. So number 2 wouldn't work out either. 3, rotation of 180 degrees centered at 1, 1. Here's 1, 1. And to check if this answer is actually correct, we just need to check if the distance between B and 1, 1 and B prime and 1, 1 are the same. So we can just find the slope of these two lines. So the slope here is 5, and the slope here is also 5. So that means the distances are the same. Alright, so the answer choice is number 3. Question number 6. Right triangle TMR is a scaling triangle with a right angle at M. Which equation is true? So we can draw out the triangle first. Number 1, sine M is equal to cosine T. Sine M is equal to 3 over 3, which is 1. Cosine T is equal to 1 over 3, so that means it's not true. Number 2, sine R equals cosine R. That automatically wouldn't be true because R is the same angle measure, and since it's a scaling triangle, all the sides are different, so it's not possible. Number 3, sine T is 2 over 3, and cosine R is also 2 over 3. So the answer choice is number 3. Question number 7. In the diagram below of triangle AED and line ABCD, line AE is congruent to line DE. Which statement is always true? So before we do anything, since these two lines are given to be congruent, I can assume that this triangle is an isosceles triangle, right? Because isosceles triangles have two congruent sides, and in an isosceles triangle, both of the base angles are congruent to each other. Immediately, number 4 is always going to be true. These other answer choices can't be proven to be always true because there's not enough information given that would prove that these are true. Even though, like, for answer choice number 1, line EB and line EC, it might look right in the diagram, but based on what we're given, it can't be proven. Question number 8. As shown in the diagram below, right triangle ABC has side lengths of 8 and 15. If the right triangle is continuously rotated about line AC, the resulting figure will be... So if it was rotated about this line AC, it would kind of look something like this. Like it would be rotated around like that, and then the triangle would be like this, and like this, all the way around. And the final shape would look something like this. So obviously it's not going to be 3 or 4 because it's not a cylinder. So right here is covered up, but the height is 8, right? And the radius right here of the circle here is 15. So the answer choice is number 1. Question number 9. In the diagram below, lines K and L intersect lines M and N at points A, B, C, and D. Which statement is sufficient to prove ABCD is a parallelogram? Number 1. Angle 1 is congruent to angle 3. This is not enough to prove that ABCD is a parallelogram, as it only proves that M and N are parallel lines. Number 2. Angle 4 is congruent to angle 7. This also is not enough information to prove that it's a parallelogram, since it only proves that these two lines right here are parallel to each other. So, number 3, angle 2 is congruent to angle 5, and angle 5 is congruent to angle 7. These statements prove that these two lines are parallel to each other, and that at the same time these two lines are parallel to each other. So this is enough information to prove that ABCD is a parallelogram, since now all these sides are parallel to each other. Question 10. Which transformation does not always preserve distance? So the 3 transformations that do preserve distance are reflection, rotation, and translation. And the only one that does not preserve distance is dilation, right? Dilation would be any sort of multiplying. So number 1 is not it, number 2 is not it, number 3 does have multiplication, number 4 is not it. So the answer is number 3. Question 11. In the diagram below, EF is parallel to HG, EF equals 5, HG equals 12, FI equals this value, and HI equals this value. What is the length of HI? So we know that EF is parallel to HG. We can also say that these two angles are congruent to each other since they're vertical angles caused by intersecting lines. We can also say that H is congruent to F since they are alternate interior angles. G is congruent to E because they're also alternate interior angles. So this makes these two triangles similar triangles. So to find HI, we can set up a proportion. 6.1x minus 6.5 over 12 is equal to 1.4x plus 3 over 5. And then we can just solve for x. We just need to cross multiply. 12 times 1.4x plus 3 is equal to 16.8x plus 36. And then 5 times 6.1x minus 6.5 is equal to 30.5x minus 32.5. So now we can just try and find x. You're going to get 5 for x, but that's not the answer since we are looking for the length of hi. So we just need to plug x into 6.1x minus 6.5. So the length of hi is equal to 24. Question 12. The square pyramid below models a toy block made of maple wood. Each side of the base measures 4.5 centimeters and the height of the pyramid is 10 centimeters. So these are all the same, and it's 4.5 cm, and the height is equal to 10 cm. If the density of the maple is 0.676 grams per centimeters cubed, what is the mass of the block to the nearest tenth of a gram? So we're given mass, density, and also base measurements. We can use the equation density equals mass over volume to find the mass. And we can isolate the mass in the equation to make things easier. We're given density, so we can try and find the volume by using these base measurements, right? So volume is equal to 1/3 base times height for this square pyramid. Volume will be equal to 1/3. The base of this pyramid would just be 4.5 squared because all the sides are the same, and then times the height, which is 10. And when you're done calculating that, you should get volume is equal to 67.5. And if we bring that back here, 0.676 times 67.5 equals the mass. And you should get 45.63 is equal to the mass, which makes number 1 the answer. Question 13. In the diagram below of right triangle EFG, altitude FH intersects hypotenuse EG at H. If FH equals 9 and EF equals 15, what is EG? So for this question, we know that this is a right angle, this is a right angle, and this is also going to be a right angle. We know that this is 9 and this is 15, right? So for these type of questions, we know that this triangle right here, and this triangle right here, and this larger triangle, they're all going to be similar triangles, right? So first, based on what we're given, the only thing we can really find is the side length for EH. So based on the 3, 4, 5 triangle, we can say that this side value is going to be 12, since 5 times 3 is 15, 3 times 3 is 9, and 4 times 3 is going to be 12. Since we know all the side values for this smaller green triangle, we can put it into proportion to find the side values. Okay, just to help you visualize the similar triangles better, we can draw out the 2 triangles right here. Okay, so we need to find EG, right? So all we need to do is just set up a proportion since these 2 are similar triangles. So 12 over 15 is equal to 15 over question mark. And all we have to do is just cross multiply and solve for the question mark. Okay, so the question mark is equal to 18.75. So that means that EG is going to be 3, 18.75. Question 14. In triangle ABC below, D is a point on line AB and E is a point on line AC, such that DE is parallel to BC. Which statement is always true? So we know that DE is parallel to BC, which makes these 2 angles congruent to each other because they're going to be corresponding angles caused by this transverse right here. And the same applies for these 2 angles, and also A is just going to be A. This shows that these 2 triangles are similar triangles, right? So that means that number 2 is correct. Number 1 might seem correct, but there's nothing that proves that this transverse right here is perpendicular to the 2 parallel lines. And we know that right angles only form due to perpendicular lines, so number 1 would not be true. Question 15. If one exterior angle of a triangle is acute, the triangle must be. An acute angle is just any angle that's smaller than 90 degrees. If this was the exterior angle, then that means the triangle would look something like this, which makes number 3 the answer since this is an obtuse triangle. Number 16, given the information marked on the diagrams below, which pair of triangles cannot always be proven congruent? So these are the ways that triangles can be proven congruent, and these are the ways that triangles cannot be proven congruent. So all we have to do is just look out for side-side angle and angle. So number 1, it's side, angle, which can be proven congruent. Number 2, angle, side can be proven congruent. Number 3 is side, which can be proven congruent. And then number 4 is side, angle, which cannot be proven congruent. So the answer is number 4. Question 17. The diagram below shows a tree growing vertically on a hillside. The angle formed by the tree trunk and the hillside is 100 degrees. The distance from the base of the tree to the bottom of the hill is 140 feet. What is the vertical drop x to the base of the hill to the nearest foot? Before we do anything, we know that this is 80 degrees, right? Because this whole line has to be 180 degrees, and this is obviously 90 degrees. This would be 10 degrees, since we know that all the angles should add up to 180 degrees in a triangle. To find x, we can just use trig, and I'm going to be using the angle 80. So cosine of 80 is equal to x adjacent over the hypotenuse, which is 140. We just move 140 to this side, and then we can solve for x. Okay, 24 is equal to x, so number 1 is the answer. Question 18. On the set of axes below, triangle LET and triangle L'E', T' are graphed in the coordinate plane where triangle LET is congruent to triangle L'E', T'. Which sequence of rigid motions maps these two triangles onto each other? Number 1, a reflection over the y-axis followed by a reflection over the x-axis. If it were reflected over the y, it would look something like this, with E here, L here, and T here. Reflected over the x, it would look something like that, right? This would be T, this would be E, and this would be L. So number 1 is not correct. Number 2, rotation 180 degrees about the origin. If it were rotated like this, then E would be somewhere here, L would be somewhere here, and then T would be somewhere here. So I don't think that's correct. Number 3, a rotation of 90 degrees counterclockwise about the origin followed by a reflection over the y-axis. If it was rotated this way, 90 degrees, then it kind of would look something like this, right? And then if it were to be rotated across the y-axis, E wouldn't even be up here. So number 3 wouldn't be correct. Then number 4, a reflection over the x-axis, which would look something like this. Then rotated 90 degrees clockwise about the origin, it would look something like this, right? With E here, T, and L, so number 4 is the answer. Question 19. Diameter ROQ of circle O is extended through Q to point P, and tangent PA is drawn. If measure of arc RA is 100 degrees, what is the angle measure for P? This angle right here is a right angle because it's where a tangent and the radius meets. This is 90 degrees. Right here is going to be 100 degrees because this is a central angle, and the central angle is equal to the arc that it intercepts. This also means that this is going to be 80 degrees, since these two are supplementary angles. So we have the two angles 90 and 80 here, right? So that makes this angle right here 10 degrees, since we know that all three angles in a triangle have to add up to 180 degrees. So the measure for angle P is going to be 110 degrees. Question 20. Segment JM has endpoints J, -5, 1, and M, 7, -9. An equation for the perpendicular bisector of JM is... So we can imagine JM looking something like this, at -5, 1, and then 7, -9. And the perpendicular bisector is right here. So what we can do first is to find where the bisector bisects JM, right? So that means that it's just going to be the midpoint of JM. And to find the midpoint, we can use this formula. I'll just plug the values in right now. After you solve everything, you should get 1, -4 as the midpoint. And with that in mind, we can look at the slope formula. So the slope formula is... In the answer choices, you can see that y is the one being isolated in the equation, so we can change it up to look like this. Okay, so going back to the midpoint, we can see that x1 is 1, and then y1 is -4. So looking at the answer choices, we have to make sure that x1 here is equal to 1. So 1 and 3 would not be correct, because then the value of 1 would be -1, right? So it's either 2 or 4. So since we're given the coordinates for J and M, we can use it to find the slope of the line JM, right? So the slope of JM is going to be... So the slope for JM is this, right? To find the slope of the perpendicular bisector of JM, we can use this slope and just find the negative reciprocal of it. So the negative reciprocal would be 6/5. So looking at the answer choices, the only answer that has 6/5 as the slope is 4. So the answer choice is number 4. Question 21. Quadrilateral EBCF and line AD are drawn below such that ABCD is a parallelogram, EB is congruent to FB, and EF is perpendicular to FH. if measure angle E is 62 and measure angle C is 51, what is the angle measure for FHB? We can just mark off what's given to us. It's given that EB is congruent to FB. So right here, EB is congruent to FB. EF is perpendicular to FH, which means that right here, it's going to be a right angle because perpendicular lines form right angles. Measure angle E is 62. Measure angle C is 51. So I can see that this angle right here is also 62 degrees since it's given that these two lines are congruent. So I can assume that this is an isosceles triangle. So that means that the base angles should be equal to each other. And then since this is a triangle, right, all the angles have to add up to 180. So that means that this angle right here is going to be 56. We can also go here and find out what this angle is just by doing 90 minus 62, which is equal to 28. So this angle right here is going to be 28. And remember, we're trying to find this angle right here, right? Looking back at what's given, it says that ABCD is a parallelogram. So this shape right here is a parallelogram, which means that all the opposite sides are going to be equal to each other. So this angle right here is also going to be 51. Since I know this is a parallelogram, this angle 51 and this angle right here should add up to 180. So 180 minus 51 is equal to 126. So this big angle right here is going to be 129 degrees. And I want to do 129 minus 56 to find out what this angle measure is. Because again, we're trying to find the angle measure for FHB, which is this angle. So 129 minus 56 is equal to 73. Now we know that this angle is 73, this angle is 28. So all we need to do is subtract those two numbers from 180. And we end up getting 79. So that is the angle measure for this angle right here, which makes number 1 our answer. Question 22. Point P divides the directed line segment from point A, -4, 1, to point B, 6, 4, in the ratio 2 to 3. The coordinates of point P are... So to make this easier to visualize, I have a graph here, and I'm just going to graph. Okay, so here's how the line segment would look on a graph. So the question says that point P is dividing it into the ratio 2 to 3, right? So we can do that by separating the line into 5 parts. 1, 2, 3, 4. Okay, now we have 5 parts. The ratio 2 to 3. So point P would be like right here, right? Because there's 2 parts right here and then there's 3 parts right here. Okay. Okay, so the ratio 2/3 is also the fraction 2/5, right? What it's saying is that point P is 2/5 of the distance for A to get to B. So we can find the X and Y distances A needs to travel to get to B. For X, point A needs to travel from -4 to 6, which is a total distance of 10. And for Y, point A needs to travel from -1 to 4, which is a total of 5, right? So 2/5 of 10, just multiply it, 2/5 of 10 is equal to 4, and 2/5 of 5 is equal to 2. So all A needs to do is travel 4 units to the right and 2 units up. So we are starting from point A, right? -4, -1. It needs to travel 4 units to the right, which means it's +4, and then 2 units up, which is +2. So that makes the final coordinates of P to be 0, 1. So the answer is number 2. Okay, a more straightforward way to do question 22 would be, since you know that this is like 2/5, right? Since you know that point P is 2/5 of the way from point A to point B, you can just, still doing it by X and Y. By doing X first, you're starting from -4, right? And then you can add the distance, right? So 2/5, and we knew that the distance was 10. So this whole segment right here is 2/5 of the distance, right? Add that, and you get 0, right? And for the Y, it's -1 plus, again, 2/5 of the Y distance, which we know is 5. So after you solve that, you get 1. So then you just get the coordinates 0, 1, because this is the X and this is the Y, right? So the answer would just be 2. Okay, question 23. A line is dilated by a scale factor of 1/3 centered at a point on the line. Which statement is correct about the image of the line? The answer choice is 4. Okay, whenever a question talks about a dilation of a line and the point is centered on that line, that means that the line does not change, right? The line would be dilated on the same line. If this was a line segment and it was being dilated on this point, the new line would look something like this, right? But since this is not a line segment but an infinite line, that means that it would just still look like this, right? So the answer choice is number 4. Okay, question 24. In the diagram below of circle O, tangent AB is drawn from external point B, and secant BCOE and diameter AOD are drawn. If measure angle OBA is 36 and OC is 10, what is the area of the shaded sector DOE? So we know that OBA is 36, right? And we know that OC is 10. We also know that this is 90 degrees, since we're given that AB is a tangent, and wherever a tangent and the radius meets is 90 degrees. So we can try to find this angle, which is going to be 180 minus 36 plus 90, and you should get 54. So this angle right here is going to be 54, and this angle over here, they're going to be vertical angles, right? So it's going to be 54 as well. Okay, to find the area of the shaded sector, we can use this equation, which is theta over 360 multiplied by the area of the whole circle, right? So the area of the whole circle is pi r squared. This is basically just the the fraction of this shaded sector compared to the whole circle. For this question, it's going to be 54 degrees over 360 times pi 10 to the second power. 34 divided by 360 is 0.15 times 100 pi. 0.15 times 100 is 15 pi. So the answer is number 4.